This is the fourth video in a set of videos on modal analysis. I'm just going to pick up where I left off. What I had done was I had figured out for the system here with two masses not connected to anything, I wrote the equations of motion. I produced the matrix formulation of that. I put some values in here, and now what I'm doing is I want to see how this system behaves. So what we did in Octave was we actually, let's see, I have it here, do it real quickly. We figured out, we formed the, what I call the eigenmatrix. It's just the mass matrix inverted times the, pre-multiplying the stiffness matrix. Okay, and we found out the eigen values here and eigenvectors here. These are the squares of the natural frequencies, and these are the mode shapes by column. Okay, so with all that, let's go back to Octave. And this is my function file that contains that model, the model of the system basically, and it is a state space model. Since we had 2 by second order ODEs, we have 4 by first order ODEs, and I've formed these here in the normal format for MATLAB or Octave. And then the other file that I have here, oh, this is not good. Let me open this back up again. It looks like something's gotten goofed up. So let's open that back up again. Yeah, that's better. It may be in blowing it up, it got confused. Okay, so basically what I'm doing here, let me just kind of go through it. What I do, and I've described this to my students in Simone in Senegal. We make our model file, which is this one here. Let me save it. Okay, and then we make an execution file, and that so this file you got to follow the particular format or peculiar format, if you want to say it, for Octave or MATLAB. They're the same. And write the function that contains the state space model, and then you write an executive M file. It's just a script file for invoking, calling the ODE solver for that system, invoking the solver, and then plotting. So what I've done here, as you can see, let's look at it. I'm not sure whether I'm running this long enough. I'll have to look and see. I may have to run it longer. I tell you what, let me put in a different value for how long I want to run it. I want to run it from 0, and I'll say 5. Now I may come back and change this, and I want to do that in 2 places because I'm running it. No, I'm running it in 2 places. So I call it. Well, no, I use actually the same T-span for both of them. And then my x0 is given here, and if you look at this, these are my initial conditions for my masses, and actually what I've done is I've simply copied the ones that we got from our here it is, eigenvectors. So I'm putting them in as initial conditions. Now what happens is if you excite the system in a particular mode by giving it those initial conditions, it will only oscillate in that mode. It won't oscillate in the second mode. So I'm going to run my simulation twice and plot the results twice in 2 different files. But at first I'm going to give it these initial conditions. Like I said, this looks like the second mode shape because that's how Octave gives it back to us. But it's the lower, it's the mode shape. It's the first mode basically. So Octave is giving them back to us backwards. And I use the size of these modal frequencies to decide what's the lower mode and what's the higher mode. So the lower mode is given second, and that means that this is the fundamental mode shape, and this is the second mode here. So I've given those in, and if we go back and look at our Octave script file, you can see that. So I give as the first initial condition, I deflect. This is x1, this is x1 dot, this is x2, and this is x2 dot. So I'm starting from rest, both of the velocities are 0, and I pull both masses over to the left by 0.70711. Okay, now you can imagine what's going to happen here. I basically grabbed those two masses and moved them to the left by the same amount. So you let them go, what are they going to do? Well, you didn't stretch or compress the spring, so it's just basically going to sit there. But we want to confirm that, so that's what all this does here. Okay, I may need to change this. Let me comment out this axis command. So this was done for a system that has different values basically for the masses, and so I want to I changed the plotting a little bit. So I'm just going to comment out those axis things, and we'll see what it gives us. I'm running it for 5 seconds. I may need to come back and run it for a different length of time. But basically, it feeds in the first mode shape, which is moving them both to the left by 0.707 meters. And then I do it again, but I move the first mass off to the left by 0.707, and I move the second mass off to the right by 0.707. The initial velocities are 0, so I'm releasing them from rest. So I've actually pulled the masses apart, the spring is in tension, and then I let them go. So they should just sit there and bounce back and forth. We'll see. So now we're ready to go. I've saved all my files. This is double mass not fixed run. So we go to the command window and we type in dbl fix, double mk not fixed run. I believe that's what it is. We'll see. Good. Beautiful. Okay. Now I ran it for 5 seconds. That's okay, but I'm going to run it a little bit longer. Let me run it for maybe 8. So I'll just kill these off right now, and we'll go back to our editor. We'll change our runtime to 8. Okay, and then we'll run it again. So we go back to the command window. We run it again. And there we go. So let's take a look at these. This is the second mode. This is the first mode. Let me blow them up a little bit so that we can look at them. Okay. Well, guess what happened? Now, it's hard to see these values here, but this is at negative 0.70711. You could blow it up if you wanted to, but you can look and see. They're kind of hard to see. This is negative 0.6. This is negative 0.8. So we're looking at vertically a very kind of narrow window, and the system doesn't move off of that initial negative 0.70711. So that's our rigid body mode. There's no motion. Okay. Now what we've done here is we pull the masses apart. I believe that what I did, let's go back and look at my my DBL run editor. So I went negative on the first mass and positive on the second mass. So if we look at that, let me get that back up again. Figure 1. We need figure 2. Negative on the first mass. So the blue curve is the first mass, and I pulled it down to negative 0.707. And the red curve is the second mass. I have pulled it to the right, which is positive 0.707. And notice that they're out of phase with each other. Okay, they're bouncing back and forth. So here, the second mass has a positive value, the first mass a negative value of displacement. Here, the second mass has a positive value the first mass has a positive value. Well, let's see, the first mass has a positive value of displacement, and the second mass has a negative value of displacement. So what's happening here on the left is that the spring is in tension, and then here it's in compression. So it just swaps back and forth, and we've only excited that one mode. Now I'm over 10 minutes, so I'm going to stop and come back and say some more things about these in just a second.